Good afternoon, class. Today we're going to solve inequalities using cut points. That is assignment number 7. And let's switch to my paper. First of all, I want to remind you all of what an inequality is. So far this semester, all we've solved are equations. We know what an equation is. It's any expression that has an equal sign. But an inequality... okay, throw. An inequality I think we can get rid of this one too. What am I holding now? How about an inequality is any expression that contains a less than, a greater than, a less than or equal to, or greater than or equal to. And we'll be solving inequalities using the cut point method, and I'll be very consistent this semester. When I'm solving an inequality, I'll use cut points. I'll say, to solve inequalities, use the cut point method. And let's see, can I have one of those pages? If you look under Files on Canvas, you'll see that I have a document uploaded there called the cut point method. To solve, we're using the cut point method to solve nonlinear inequalities. It works on linear inequalities also, okay?
And make sure everyone has one.
Everyone has one of these, okay? But if you lose it, just look under Files on Canvas.
Or ask us the next class period.
Yeah, okay. To solve a nonlinear inequality, the first thing we're going to do is replace the inequality with an equal to. We're turning it into an equation. So you'll have to remember all your equation solving skills. The numbers you get here are called solution cut points because there's the solutions to the equation. Now, we'll have to be labeling these numbers on a number line. You'll use a less than or equal to or greater than or equal to for solution cut points. You'll use a closed circle. If it's just less than or greater than, you're not going to shade in the cut point. You'll use an open circle. We'll discuss that more as we go through an example. The second step, the first step you're asking yourself, where is the inequality equal? The second step you're asking yourself, where is the inequality not even a number? Where is it undefined? Well, we know when a fraction's undefined when the denominator is equal to 0. So set any denominators not equal to 0 and solve for x. These numbers are called denominator or domain cut points. Now, for denominator cut points, you never want a denominator of 0. So it doesn't matter what the problem has, what the inequality is. Denominator cut points will always be labeled with an open circle. Then you'll draw the number line and label the cut points. You then have to select a number in each interval and test the inequality. If it's true, you'll shade the interval. If it's false, you'll cross it out. And then the final step, express the shaded intervals using interval notation. That's why we were going through interval notation at the end of class the last time. Remember, we said use square brackets for closed circles. Any other symbols, grouping symbols, have to be parentheses. Use parentheses for open circles, parentheses for infinities or negative infinities. You only have a square bracket at a closed circle. To illustrate all of this, I think we'll go through we'll start with number, where's my class notes? Do I want to start at number 1 or 2? These are my class notes for the semester. Yes. My goal is to get the entire semester's notes on one sheet of paper. And trust me, we will. We always do. So here it is. Number 1. Oh, click on it. I don't know what the problem says. Oh, goodness. X squared minus 13x. You'll notice it doesn't say anything about cut points. It doesn't say, what about number 2? Maybe number 2's better.
I think that might not be a bad. Which one are you doing?
I like number 2 better.
Okay.
What do y'all think?
Then let's do number 2. It'll show the steps, I think.
This is number 2.
But notice it doesn't say anything about cut point. What you've got to get into your head, that student years ago that said his crazy teacher told him
to read the instructions. If it's an inequality, well, the instructions here aren't going to say use cut points. It's up to you to know. To solve an inequality this semester, we'll be using cut points. Make sure I didn't miscopy. 5x squared plus 18x is less than or equal to 8. So we're going to read the instructions. We'll read this little cut point recipe and go through the steps. The first thing it says is replace the inequality with an equal to and solve for x. I'm going to they don't need to see that. They have their own, okay? I'm going to number the steps just to draw a connection between what's written on that sheet of paper and what we have here. I should have opened up the PDF, I suppose, but no.
So this is step 1. Replace the inequality with equals.
Replace the inequality with equals and solve for x. This becomes a quadratic equation. That means we'll solve by either factoring or the quadratic formula. Either way, what do we need to do with this 8? So we have 5x squared plus 18x minus 8 is equal to 0. And these numbers are going to have to be, we'll be labeling them on the numbers we get, we'll ultimately label on the number line. Now, you could wind up with irrational numbers. This may be something that you have to use the quadratic formula for, but I've found that with my math lab, they're always going to make sure that these things are factorable. They don't have to. They're just being nice, okay, to give you rational numbers to make it easier. You don't have to get a calculator and get a decimal approximation to figure out where the cut points are labeled. I'll write my 2 sets of parentheses. 5x squared, the only possibility is a 1x and a 5x. What do we know about the signs? Okay, that last sign's a minus, so we have 1 of each sign, 1 plus, 1 minus. Now for 8, what times what equals 8? It's only 2 possibilities, 1 times 8 and 2 times 4. I think we're going to need a 2 times 4. Do y'all see it? Put the 4 here, the 2 here. That's a 20x. That's a 2x. We can subtract them to give us that 18x. Where would we need the plus sign in order to get a positive 18x? Do we need the plus sign in front of the 4, or should it go in front of the 2? In front of the 4, I agree. So if you check the outer and inner, the outer is a negative 2x. The inner is a positive 20x. Negative 2 plus 20 gives us a positive 18x.
So you're just checking your factoring to make sure it's right.
Set each factor equal to 0. To give us x equals here negative 4. Now this is not something you're going to type in. That's just the first of our solution cut points.
It's going to be one of those numbers on your number line.
The number line. The next one. Well, add 2 to give me 5x equals 2. And then divide by 5 to give us x equals 2/5. The numbers you get when you solve the equation are called solution cut points. Now, negative 4. If you plugged in negative 4 here and here, you'd get a negative, no, you get a That's an 80 minus 72. 80 minus plus a negative 72 would give you a positive 8. Is it okay for the left side to equal the right side? Is equality okay? Yes, because it has that horizontal bar. So these solution cut points here will be labeled with a closed circle. You're shading in that number. If the problem contains a less than or equal to or a greater than or equal to, use a closed circle. If it had just been a less than or a greater than, we would have used an open circle.
Why?
Why? Because for a closed circle, that means you're including the number. These
statement.
numbers make it a true statement. 8 equals 8. If you plugged in 2/5, you'd still get 8 on the left side, and that equals 8 on the right side. If there hadn't been that horizontal bar, 8 is less than 8, that's false. That's why you would have left it as an open circle.
So open circle means do not include as an answer. Is that what you're saying?
Yes.
Okay.
Step number 2, set any denominators not equal to 0 and solve for x. These numbers are called denominator or domain cut points. Look at this problem. Look at the original problem. Are we going to have any denominators of 0? In order to have denominators of 0, your problem must contain what? Starts with an F.
Not FOIL, not factor. In order to have a denominator, there
A
must be a
fraction. There's no fraction. This is a polynomial inequality. So we just skip. Second step, we'll skip because there is no fraction.
Maybe handwrite that out here, out beside rule 2. Skip rule 2 if
You
there's no
skip
fraction.
if the problem has no fraction. Skip if
No fraction.
no fractions. Third step, we draw a number line.
Want to move it up a little? And you laugh when I say this, but students mess up.
You always label, this is a number line. You label your cut points in numerical order. So we're drawing a number line and we're labeling the cut points. We have 2 cut points, here and here.
Don't label any
Which-
other number.
That's right. The only numbers you should label on the number line are the cut points themselves. What's going to go first? -4, a negative number is always smaller than a positive number, and we shade them. The cut points are shaded circles. The only time this inequality, the step on the left, can change from less than 8 to greater than 8 is when the inequality is equal to 8, or else it's just not even a number. Well, that not even a number, the undefined situation doesn't occur. It's impossible for this to be less than 8 at -5, but greater than 8 at -6. No, the only places it can change, or possibly change, are at -4 and +2/5. So look at the fourth step. Select a number in each interval and substitute it into the original inequality. If the inequality is true, we'll shade the interval. If the inequality is false, we're going to cross out the interval. This is where we're figuring out whether we shade or cross out the intervals. Remember, at the end of class the last time, we were practicing with interval notation, and I said that we'd have some intervals crossed out and some shaded. This is the step where you figure out which ones you shade and which ones you cross out. So this is step number 4. Choose a number in each interval. Choose a number to the left of -4. Now when you're testing, you can't test the cut points. So you need a number to the left of -4. I could use -5. I could use -7.4398. I could use -10. I think -10 might be 10 is an easy number to plug in, isn't it? Maybe we'll test -10. Now between -4 and +2/5, what number do y'all want to test? There's one number that's always between, right in the middle between negative and positive numbers. And it's an easy number to plug in. 0, I agree. 0 is my favorite number to plug in. It's just so much easier. And finally, we need a number to the right of 2/5, something bigger than 2/5. We could plug in 50,000 if we wanted to, but I think there's a number to the right of 2/5 that would be real easy to plug in. What do y'all think? What number do you think would be an easy number to plug in for x? 1, I agree. I'm going to use 1.
But you could have used 2, 3, 4.
I could have used pi, 3.1415.
That would have just been incredibly stupid, though.
But I could have. I know, but it just makes the point. If it's true at one number in that interval, it'll be true at every number. So if I get a true statement, if I test 1 and get a true statement, and you test 3 and get a false statement, one of us is wrong. Okay? It's either true at every number in the interval or it's false at every number in the interval. Let's see. Start at -10. We're plugging it into the original inequality, the thing with the less than or greater than. Don't plug it into the equal to. Plug it in for either the less than or the greater than. Plugging in -10, we get 5 times -10 squared plus 18 times -10 is less than or equal to 8. And remember your order of operations. You do the exponentiation first, or else you do what my brother's doing and just punch it into a calculator. That would be, you do the exponentiation first. 100 times 5, I'm getting 500. That would be minus 180. Is that less than 8? True or false? Is 500 minus 180 less than 8? What is that? 320? 320 is less than 8? False. We cross it out. If the inequality is false, cross out the interval. If the inequality is true, shade the interval. Testing 0, what are we about to get? That's going to become a 5 times 0 squared. That's just a 0 plus 18 times 0 is 0 is less than or equal to 8. 0 plus 0 is, that looks funny. 0 plus 0 is less than or equal to 8. True. So we shade. What do y'all think? If you suppose this were a test question and you're running out of time, you either had to shade it or cross it out. What would you assume? What would you do? Odds favor that they alternate. That odds favor it'll either follow false, true, or true, false. Since this is true, this one's probably false. Let's verify that. Plugging in a 1. 1 squared is 1 times 5 is 5 plus 18 times 1 is 18. 5 plus 18 is less than 8. True or false? False. That says 23 is less than 8. That's false. Cross it out. Fifth and final step. What do we have to do? We now have our number line. We have our intervals crossed out. We have one of them shaded. What's the last step? Express the shaded intervals using interval notation. So this is step number 5. I'll see which of you, how many of y'all remember what we were doing on at the end of the last class. You're going to have to type this stuff in. Pretend you were typing. The interval notation always goes small to big, left or right. You have to read it as such. So I'll get us started. We're either going to type a parenthesis or a bracket. Which one? I couldn't hear you. I heard someone say something, but I couldn't hear it. Bracket? Okay. That's the only time you use a bracket is when you have a closed dot. Then you have a -4, comma. Don't forget to type your comma. The right-hand endpoint is 2/5. What are we going to put on after that 2/5? Another bracket. This is an interval of this form that has starts and ends with the bracket is called a closed circle. A closed interval. A closed interval is a number line that starts and ends with closed circles. Here's what you'll type in.
I have a question, Tim. Does it matter the order? Could I have written 2/5, comma, -4?
I think I've already answered that question.
Well, I'm just
Y'all tell me, what does that matter? Could I have written 2/5, comma, -4? No, you cannot. You must write it in the order of a number line, small to big. So, typing in our answer. And the bracket just comes from the keyboard. And the last time I think I was pointing out the bracket is beside the letter P on a standard keyboard.
Y'all think it's going to count it wrong? Right?
It should count it wrong. So I don't
see what I did wrong.
You put that bracket down there in the denominator.
It's circling. You don't know. There's something wrong. You don't know what it is. Now, a word of warning. They never, ever say cut points.
They don't use this terminology.
Talk you through.
You'll find those numbers, but they never refer to them as cut points. But I think we need something to call those numbers that are labeled on the number line. Correct the problem.
I'm going to hit the right arrow to get out of there. Then put.
And I have an example that I've made up that I want to do.
And then
okay, switch on. This is number 2. So not number 2, it's just an example. I'm going to label it EX, for example. When I write an example notation, I still convert to my old cursive writing.
Because of your beautiful penmanship. We know.
Some people are just so jealous that I won all those penmanship awards in elementary school.
Well, Misty told me today that she was really jealous
of my penmanship. That's worthless now. So I was able to write cursive real neatly. But thanks to the arthritis in my finger, even if y'all could read cursive, it wouldn't look that good anymore. I had to, I'm recording, okay, so let me go on. So I want to solve this equation. To solve this inequality, when I go off on these tangents, the transcripts that YouTube generates for every video that's uploaded, their little AI thing doesn't really know what's going on. So I need to not go off on the tangents because YouTube AI may decide that I need to be eliminated, that I'm not a productive member of society. So I better.
Well,
I don't
Tim,
want to
he's
do
going
that.
to know that now.
But I am a productive member. Maybe I won't upload this video. Okay, this example is important. If you understand what we're doing here, at the end of this problem, we're going to have a way of looking and deciding, do we really need to check every interval individually, or can we just check one interval and then assume an alternating pattern? Do y'all know what I mean by an alternating pattern? True, false. You don't have a true, true, false, or a false, 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 true. If one interval is true, the one beside it has to be false. So let's look at this one.
Tim, how do they know to do cut points even though you don't say?
I'm not telling. How do y'all know? How do y'all know? Because of that inequality symbol. And you know you're going to follow your 5-step cut point recipe. First thing we'll do, set it equal.
They're going to have to do
X squared minus 14x plus 49 is equal to 0. And unlike that problem we just did, we already have a 0 on the right-hand side. We don't have to try to move terms around. Let's write our two sets of parentheses.
What about the signs?
We know something nice about the signs inside the parentheses. Okay, the last sign's a plus, so you have two of the first signs. I'll write my minus and my minus. X squared, we know what goes here and here. X times X. Now for 49, it's either 1 times 49 or 7 times 7. Okay, for a simple trinomial, you choose the pair that adds or subtracts to give you that number right there, and 7 plus 7 gives you a 14. If we FOIL that back out, are we going to get the minus 14x that we needed? Oh, this is nice. We have the same. How many solution cut points are we going to get here? We take x minus 7 and set it equal to 0. That gives us x equals 7. Set the second set equal to 0, what happens? That's the same thing. We only have one cut point. Okay. We have one cut point.
Open or closed circle?
It'll be an open circle because 7 will make the left side equal 0. If you plugged in 7, you'd get 49 minus 98 plus 49. You'd have 0 is less than 0. Is that a true statement? Is 0 smaller than 0? It's equal to, it's not less. That's why you don't want to shade it in. If it had been a less than or equal to, that would have been a true statement, so we would have shaded the solution cut point in. But as it is, it's just an open circle. The second step, our denominator cut points. What do we conclude there? The second step, set any denominators not equal to 0. What did I say you do? Skip it if there's no fractions, so we skip. Third step, we draw our number line and label the cut points. This is really nice because we only have one cut point. And we said it would be open. Step number 4 is the checking. You have to choose a number to the left of 7 and a number to the right of 7. Well, we could use 6 and 8. We could use 5 and 9. But I'm going to use numbers that are easy to plug in. To the left of 7, I think I'll test 0. And here's one thing you're going to notice. When I'm testing, if an interval contains a 0, that's the number I'm going to test. 0 is in this interval, so I'm going to test 0. Now, to the right of 7, we're going to have to square. You know what's easy to square is 10. Is 10 in this interval here? Yes, so I'm going to test 10.
8, 9, 10, 11, 12, all the way out to infinity.
You could test 50 billion if you wanted to, okay?
Do you remember that workshop?
I remember that workshop. So, plugging in 0, we're going to get a 0 squared, which is 0, minus 14 times 0 is 0, plus 49 is less than 0. That reduces to 49 is less than 0. True or false? False, so we cross out the interval to the left of 7. Now, what did I say we were going to test over here? 10. If you want to do 8 or 9, we'll still get the same result at the end. It's impossible for me to say shade and you say cross out, and we're both correct. It doesn't matter which number you test. You could test 9.45. We'll still get this, or 7.1. I'm testing 10. 10 squared is 100, minus 14 times 10 is 140, plus 49 is less than 0. So that's 149 minus 140 is less than 0. I'm getting 9 is less than 0. Shade or cross out. Is that a true statement? No, we cross that interval out as well. We had two consecutive intervals, both of which are false. What's shaded on that number line? Nothing. So step number 5, there is no solution. We don't have a shaded interval. Well, how did that happen? I just finished saying that most of the time it'll alternate. If this one was false, I bet you most of y'all thought this was going to turn out to be true before we plugged in. That's a standard assumption, but there's something that happened. There's something different about this problem versus this one over here. We still had to get it set equal to 0 and factor, but there's something different between number 2, a fundamental difference between number 2, that problem that we started with, and this example here. What's the fundamental difference? It only had one factor. It had repeated factors. X minus 7 times x minus 7. That's the same thing as x minus 7 quantity squared. It doesn't matter what you plug in here. When you square it, even if the stuff inside there's negative, when you square it, what is that going to give you? You're going to get a positive number. It's never going to be less than 0. Once again, it's the even multiplicities, those even exponents. In the factoring stage, now if your inequality only involves a linear numerator and a linear denominator, if it doesn't have any quadratic expressions, then you can rest assured, yeah, it's going to factor. It's going to alternate. But if there are quadratic expressions and you can factor it so that you have repeated factors, then you better check every interval. So I'm going to say, note,
so by
if you have repeated factors, do you understand what I mean by that? That's what we had here. We had x minus 7 times itself. The exact same thing inside the parentheses. Repeated factors. You need to check every interval. It may not alternate. Check every interval. If the factors are different, or if you don't have any quadratic expressions at all, I'll say no repeated factors.
Or no factor.
No repeated factors. Or if there's no quadratic expressions, I'll say no exponents. In order to have a quadratic expression, look at this thing. To have a quadratic expression, you had to have that x squared. So I'll say if there's no repeated factors or no exponents, you can just check one interval and assume an alternating pattern. But you better make sure you check that interval correctly. I'll say check only one interval and assume an alternating pattern.
And that's a correct assumption. It'll always alternate if there's no repeated factors.
It's those even exponents. It's those things that mess up or the reason that we have imaginary numbers. It's those even exponents, the way it takes things that could be negative and changes their signs to positive. But this will save you a lot of time. And I'll give you some advice also. What I'll do is I'll label my number line, I'll label the cut points, then I'll ask myself, where's 0? Now if 0 is a cut point, you can't test it. In that event, I'd test 1. That's easy to plug in. But I'll find which interval contains 0, and I'll test that interval. If it's true, I'll shade, make an alternating pattern. If it's false, I'll cross it out and assume the things beside it are true. But that will save you quite a bit of time. I think I saw a hand go up over here. No? Oh, okay. I saw something I thought out of the corner of my head. Way back there, question? No? Okay. let's do number 3. Now number 1 was easier than the number 2 because it was a simple trinomial. So let's go on to number 3. I'll leave number 1 to y'all. X times x minus 1 is less than or equal to 2. Okay, switch. First step.
What do they have to do step 2?
Will we have to do step 2? Or no, because there's no fractions, no denominators in the problem. When you look at the problem, you know immediately we'll skip over step 2. Eventually, we'll get some where we have to do step 2, and I want y'all to yell it out as soon as you see it, okay? So, step 1, replace the less than with an equal to. Too bad that's not a 0 there, but it's not a 0, so we're going to have to get rid of the parentheses by distributing the x. That'll give me an x squared minus x, and then I'll move that 2 over to get minus 2 equals 0. I can already tell that this is not going to have repeated factors. Go back, I can tell right now, we have to factor this, but we're not going to have the same thing inside the parentheses. Here's one thing you may want to remember. When you're factoring, if you're going to have the same number there and there, that means that last constant term has to be a perfect square. 2 isn't a perfect square, so we're going to have different numbers in the parentheses. We'll be able to assume an alternating pattern. What do we know about the signs? Okay, I think I'll just write a plus and a minus, and I'll be careful where I put the constant terms in a moment. X squared, we know that's going to be x times x. And so for 2, there's only one possibility. What is it? 1 times 2. Okay, where should I put the 1? Should I put it after the plus or after the minus? I guess a better question is, where should I put the big number 2? The big number will go where the negative is. I think the 2 is going to go here. So the ones that said to put the 1 at the plus, they were right. Check the outer and inner product just to make sure. Falling out, what's the outer product? Negative 2x. What's the inner product? Negative 2x plus 1x. That gives us a negative 1x. Is that what we needed? Yes. Notice we don't have the same thing inside the parentheses. So I know when I draw that number line, I'm only going to check one interval. I'm not going to bother checking every interval. Oh, step number 2, denominator cut points. What do we conclude? Oh, wait, I didn't finish this, did I? Setting x plus 1 equal to 0, that gives me x equals. Setting x minus 2 equal to 0, that gives me a positive 2. These are my solution cut points. How will I label them? I'll give you a hint. It's either going to be open or closed. Which one? Closed. These numbers make the left side equal the right side, and we have that equality bar there. So these will be closed circles on the number line.
Years ago, a student said in class, I have a way of remembering that it's with the equal sign that you put the closed circle. Do you want me to tell the class? And I said, well, yes, tell me.
Is it vulgar?
No.
Oh, okay.
But she said, look at the symbols. What uses more ink, a closed circle or an open circle? Well, a closed circle would take more ink or pencil, whatever you're using, to shade it in. And she said, which symbol uses more ink? The one with the equal sign uses more ink, and that was her little more ink method.
Okay.
If there's a closed circle, then use the symbol that uses more ink, the one with the equal sign. I guess it's not a good way. Well,
Yeah, it's a
thought
good
it was
way.
really
Step
good.
number 2, what will we do? Skip it because there's no fractions. You'll know the ones that have fractions, okay? Step number 3, we draw a number line. We have 2 cut points, and it does seem like most of the homework problems, not all of them, but most of them have 2 cut points. Which one will go to the left? -1 and then +2, and we said that they're closed circles.
I'll tell you, just thinking your way through these is not a trivial matter. When
And
I
it was
first
hard
saw
to
these steps, I thought, oh, wow.
I thought it was crazy. What
Yeah,
are they
it was-
doing? What is she doing with this?
But oh, wow.
Okay. Step number 4.
How many intervals do we have to test? Just one, because
Just
it's
one.
going to alternate.
Misty Star was actually answer. She knew, she was reading my mind and knew that the next question I was going to ask was, which interval do y'all want to test? And she was saying interval 2 because she knows what's my favorite number to plug in. What's the easiest number? 0. And 0 is between a negative and a positive. So we're going to test 0. You plug it in. Don't plug it into the equation. The equation will never be true, okay? You got to plug it into the original inequality. 0 times 0 minus 1. What does that give us? Well, 0 minus 1 is -1, but the product, once again, you're ahead of me. 0 times -1 is 0 is less than or equal to 2, true or false?
Is 0 smaller than 2?
Yes. So, once again, we shade. Step number 5, call it out.
Call out the rest, finish the rest of the...
Oh, yeah. So, if it's true here, if I'd tested -2 over here, what would have happened? You'd cross it out. Suppose we had tested 3 or 30 over here, what would happen? Shade or cross out? Cross out. 5th and final step, call it out as if you were typing it. What would you type first? Bracket, and then, not 0, -1, comma, 2, and what goes after the 2? Notice, the test value that you choose is never going to be typed in as part of your answer. That's why I don't put a little tick mark there and put a 0. If I label any number other than 0, than the cut points on the number line, then invariably people start wanting to type those numbers in their answer. The only things that can appear in your answer are, the only numbers that can appear in your answer are cut points. You tested 0, but did you type a 0 in your answer? No. The only thing you can have in your answer are cut points. If it includes this interval, you'd have a positive infinity. If this interval had been shaded, we'd have a negative infinity. But the test values themselves do not appear within your answer. Any questions
I'm going to
there?
type this in before we get timed out. So bracket, -1, comma.
It's not typing.
Oh, no.
So closed circles is brackets, correct?
Correct. That is an open is parentheses, and infinities and negative infinities are also parentheses. Look at the there, the last print thing I have on number 5 on that handout. And I'm trying to guide you through that right here when I say square brackets. You only use those for closed circles, parentheses for open circles, parentheses for infinities or negative infinities.
Years ago, I had a student say, is it true, could I write a rule, or could I say that if there's not an equal sign in the original problem, then all you're going to have in your answer are parentheses. And that's
Correct.
true. That's correct.
There was this problem, here no interval checked, but I knew there wouldn't be any brackets in my final answer because there was no equality here. Number 5, we'll go back to number 4 after number 5. I want to do number 5 first. Solve the inequality. X divided by x plus 5 is less than or equal to 2. That's
right.
correct. We are not going to skip step 2. And how do you know we're not going to skip step 2? Because that problem, you see that fraction there. So we're not going to be able to skip step 2. But first step, replace the inequality with an equal to. So you have an x divided by x plus 5 is equal to 2. And you know what I'm going to do? I'm going to write that as a 2 over 1. Can y'all guess what I'm going to do now? Cross multiply. X times 1 is 1x equals 2 times x plus 5 gives me a 2x plus 10. Don't forget to distribute the 2 over the x plus 5.
Are we going to have to factor on this one?
Are we going to have to factor? No, there's no quadratic expressions. So whatever numbers we get as cut points, we'll be able to assume an alternating pattern. I think I'd move this x over here and move that 10 over to the, I'll take the x on the left and move it over to the right. I think I'd move the 10 from the right over to the left. So you have 2x minus 1x gives you 1x equals, what are we going to have here on the left side? Negative 10. We only have one solution cut point.
Open or closed?
Open or closed. There's equality, so we're going to label that negative 10 with a closed circle. Second step. Set any denominator that's not equal to 0. Set any denominator not equal to 0 and solve for x. I see a denominator in the original inequality. I had it, the others that we've done so far didn't have a denominator. You don't want a denominator of 0. That means that x cannot equal move the 5 over to get x doesn't equal negative 5. And that is my denominator cut point. Be careful. How do we label our denominator cut point? If you took that negative 5, you get a negative 5 divided by 0. Is that a number? No. That's why I say for denominator cut points, it doesn't matter what the original inequality is. For solution cut points, you have to look back at the original inequality. But for denominator cut points, always label with an open circle. Remember, we were solving rational equations. We had to go through, we don't want this denominator to be 0. So it's that same logic there. Denominator cut points, always open. Third step, we draw our number line, and we have 2 cut points, there and there.
Label them in numerical order.
Which one will I label first? Negative 10 is smaller than negative 5. Negative 10, we said we'd label with a closed circle. Negative 5, that'll be an open circle. I warned y'all the last time when we're going through with the number line, we'd have some cut points labeled closed and some would be labeled open. This is the first time that we have one where the numbers are mixed together. Notice we have no repeated factors. We don't even have any quadratic expressions. So step Number 4, I'm only going to test one interval and assume an alternating pattern. What's my favorite number to plug in? 0. Which interval contains 0? Interval 1, 2, or 3? Okay, so 0 is over here to the right of 3.
0 is always between a negative and a positive. There's not an endpoint labeled here, but he just labeled it.
A positive infinity. To find 0, 0 is always between a negative endpoint and a positive. Testing 0, we get 0 over 0 plus 5 is less than or equal to 2. 0 divided by 5. Don't say undefined. What's 0 divided by 5? Just 0. Remember, 0 divided by some non-zero constant? That's okay. It's okay to have 0 on top. It's the 0 in the bottom that says no. That's when it's undefined. So shade or cross out. Shade. That's a true statement. 0 is less than 2. Suppose we had tested negative 6 or negative 8. Would we shade or cross out? Cross out. What about to the left of negative 10? What do we expect to happen? Shade. So remember, way out here, we denote that left-hand arrow as negative infinity. The right-hand arrow, we interpret that as a positive infinity. So step number 5, interval notation. I'll get us started. We're reading from left to right. There is no left-hand endpoint. It keeps going forever. So we put a parenthesis, negative infinity, comma. The right-hand endpoint is negative 10. What do we put after that negative 10? A bracket because it's shaded in. Or, I mentioned this the last time, you connect intervals using the set union notation, and you'll get that from the toolbar. You'll get the infinity from the toolbar also. Everything else, I just use the keyboard. Now, y'all call this second interval out as if you were typing it in. What would I type first? Parentheses, negative 5, comma, infinity, parentheses. Good.
I want you to stop and imagine just thinking about it. You're sitting there thinking, oh, wow, this is a long process, a lot of steps. It could be worse. It could be a lot worse. Just think about it.
That was the one time I'll remember that teacher.
I never
This
gave
person's
a bad teacher
bad evaluation because you always had to fill out what's your major, what's your current GPA. There weren't that many math majors with a 4.0 GPA. As a matter of fact, we made, when we graduated with our bachelor's degrees, we made all, back then there were these things called newspapers. We made all the papers in the state, okay?
Yeah, we were once smart.
We were once
Considered geniuses. But, what was I going to say? But thinking your way through this,
you have to, if you know what you're doing, okay, yeah, I can think my way through it, okay?
But if you don't have a degree in math, thinking your way through it, when I first saw that sequence of steps, that's when I was getting ready to teach it, and I thought, oh, wow, now my brother meanwhile was like,
what is this craziness? We need to think our way through this stuff.
I need to memorize this sequence of steps, and I was like, but Tim, look at it. Just give it a try.
It was Dr. Hickey that convinced me otherwise that I needed to follow those steps.
I've got to type this in.
Type it in before we get, okay.
Parentheses,
negative infinity, comma, negative 10, bracket, union. Do y'all see? Look there. There's another little symbol that looks like a set intersection. That would You shouldn't use that intersection symbol. That union is read as or. The numbers to the left of -10 or the numbers to the right of -5. There are no numbers common to both of these sets here. And also I should have pointed out, when he was typing in the negative infinity, there is no negative infinity hot button. You have to type the negative from your keyboard and then the infinity. I'll get emails from people worrying because they can't find the negative infinity. Infinity is like a number. If you want to type 5, you just type the 5 from the keyboard. If you want -5, what do you have to do? You have to put that dash in front yourself. So negative infinity, you type the dash from the keyboard and then the infinity. Any questions there?
See, we're going back to number 4.
Now we're going back to number 4. Here's my question for number 4. When we're drawing our number line, will we have any closed circles? Will there be any closed circles on number 4? You should be able to look there, and after you analyze the problem, you see there's no equality possibility. So your number line can't have closed circles. So step number 4.
Will there be any square brackets?
Yeah, when you're writing that final answer with interval notation, will you have square brackets? If you don't have closed circles, you can't have square brackets. So
a student once said, if it's just strict less than or greater than, no equal sign, nothing but parentheses in your final answer.
And that's correct.
And I was like, yes, that's a rule that's always true. He went off to Rice. I wonder what happened to him. Oh, anyway.
Okay, -3 divided by x minus 2 is greater than -1. First, are we going to get to skip step number 2 on this one? No, you see the fraction? That means you're going to have to find those denominator cut points. But the first thing we'll do is find our solution cut points. Set -3 over x minus 2 equal to -1. What do y'all think I'm going to do here to solve this equation? I'm going to put that over 1, and I'll cross multiply once again. Remember I said that when we were solving rational equations that you'd be surprised how many times you wind up with fraction equals fraction as we go through the course, and that's an easy way to solve it. Just cross multiply. -3 times 1 gives me -3 equals, be careful, -1 times x minus 2. What's that going to give us? Negative x, keep going. Okay. Distribute the -1 over the x minus 2 to get a negative x plus 2. Are we going to have to factor here? Are we going to pick up any exponents? No? So we can assume an alternating pattern. When it gets to checking, we can assume an alternating pattern. I need to solve for x. What do y'all think I'm going to do? Oh, I wouldn't do that. I just want the x by itself. So maybe I'd take the x and I'd move it to the left. Why would I do that? What would happen to that negative x? It becomes a positive x. So just x equals, although I'm very good with when it comes to working with negative numbers, I try to avoid them for students' sake. And this avoids negatives. Add the x, then what do I do here? Add the 3 to give us x equals 5 for my solution cut point, and we've already said that's going to be an open circle. Step number 2, denominator cut points. You take any denominator that appears. If there's more than one denominator, you're going to have to use them both. But there's only one denominator, x minus 2. You don't want that to equal 0. So that means x cannot equal 2 for my denominator cut point. How will I label that? Denominator cut points are always open. The solution cut point, we looked at that thing there and there was no equality. Remember I said if there's no equality bar, then The only sort of circles you can have on your number line are open circles. Step number 3, you draw your number line. And I have 2 cut points. Which one will I write here? Which one will be on the left? 2, remember you have to go small to big. Small to big, and we said open circles. And step number 4, what will I do next? Test. I've already said that we only have to test one interval. What number do you think I'll test? 0. As long as 0 isn't a cut point. I remember last semester we were doing a problem and 0 turned out to be a cut point. Well, then I tested 1, okay? But you can't test 0 if it's a cut point, but for practically all the problems, for most of the problems, the vast majority of the problems, 0 isn't. Now, which interval contains 0? Interval 1, 2, or 3? 1. 0 is to the left of 2.
0 is always between a positive and a negative.
Negative infinity and the positive, that's where 0 is. So we're going to test that first interval, 0. That gives me a negative 3 divided by 0 minus 2 is negative 2. Is that bigger than negative 1? Negative divided by negative is positive 3 halves. Positive 3 halves is bigger than negative 1. As soon as I saw that the left side was positive, any positive number is bigger than a negative. So shade or cross out, shade. Suppose we had tested 3 or 4. What do we expect to happen in the middle? Cross out. Suppose we had tested 6 or 10, shade.
It's really convenient when you know, oh, it's going to alternate. Just test one interval. I remember back before we told them just test one interval, and we did like the viewing example books do where they test every interval. The students would mess up a lot more.
Yeah, there'd be all these true, false situations. Those are very rare. Those are very rare. But people would mess up checking, and so they'd wind up with, sometimes they'd have true. That's incredibly rare, okay? But I'm waiting for y'all to call it out as if you were typing it in. Let's start with the first interval. I'll get us started. Parentheses or bracket. Hey, mate, wait a minute. I think we made an observation earlier. Will we have any brackets anywhere? No, because there was no equality. So I agree. We need parentheses. And then negative infinity, comma, 2. And don't forget the comma. Close your bracket. Or, now the next one. Parentheses. 5 and a positive infinity, parentheses.
The false interval should not be part of the answer. The reason we started crossing them out is we noticed students,
they just go interval notation crazy and write out every interval, even the ones that were false. No, you do not. The intervals that you cross out are not part of the solution. Okay, I have a question for y'all. If I plugged in 50 million, does 50 million satisfy that inequality? Would 50 million make the left side greater than negative 1? Is 50 million in one of these intervals? Yes, 50 million is to the right of 5. What about negative 50 million? Would negative 50 million make the left side greater than negative 1? Is negative 50 million in one of those intervals? Yes, it is. It's to the left of 2. What about pi? 3.1415, whatever. Would pi make the left side greater than -1? No, 3.1 is right here between 2 and 5. It's crossed out. So these intervals are telling you which numbers you could plug in at. There are infinitely many of them. Which numbers can you plug in so that the left side is greater than -1?
Wow. You're finding infinitely many solutions.
I know.
It's just amazing. Parentheses.
Oh, you haven't typed it in?
Typed it in. Parentheses. Negative infinity, comma, 2, close parentheses, union. I wonder what would happen if I put the intersection
We don't have
and got
time
it.
for that.
Okay, yeah.
You think they would say, hey, you've used the wrong symbol? Check it. I'm just curious.
Uh-huh.
Or are they just going to give you the general?
Okay, you see, look at how they tell you to do it. They find the denominator cut points first
Then the solution.
without
cut
ever
point.
using the word cut points. But to answer the question, did it know what was wrong? No. They didn't say, hey, should be the union.
There's nothing in that intersection. There's no numbers that are both less than 2 and greater than 5 at the same time. It should have said, hey, there's not. You're saying no solution there.
5, 6. You doing 6 now?
Mm-hmm. Oh, this is a good one. This is going to have more than 2 cut points. We're going to have more than 2 cut points here.
And I think we might have an opportunity to factor something that we haven't factored yet.
We'll see. Z divided by Z minus 4 is greater than or equal to 2Z.
Years ago, I had to do a review for this book, and I remember saying, oh, replace those Z's with an X. What can you do to make it better? Replace the Z with an X. They didn't listen. But why am I saying Z's invariably, how many people wind up with thinking this is 22 before it's all over there? Okay, so often people write the Z and then they look back at it and think it's a 2.
First step, we've replaced the greater than or equal to with just an equal to. And I'm going to rewrite that 2Z as 2Z over 1. And then I will cross multiply. Z times 1 is Z equals, be careful, you're going to have to distribute the 2Z over the Z minus 4. That's going to give me a 2Z squared. Okay, a negative 4 times 8Z gives us a negative 8Z. Any questions on my logic there?
Are we going to have to factor this one?
Yes, because I see this Z square, but, oh, I'm sorry for that static. Let's see. Okay, I still have some. Yeah, I know. Okay. We haven't factored something of this form yet.
This is about to fall off.
There. We haven't factored a polynomial of this form. Notice we have a Z and a Z. Or we can move that Z over and combine it with the other Z. That's a positive 2Z squared. Remember, you want your leading coefficient to stay positive. So I think the easy thing to do is to subtract Z from both sides to give me 0 equals 2Z squared minus, be careful, you have a negative 8Z minus 1Z. That's going to give you a 9Z. This is not a trinomial. We may run into factoring a difference of 2 squares later on in the semester, but I think this is the first time we factored something with 2 terms. Here, when we look at this, we see that we have a common factor. Both of these terms have what in common? Z. You can take out a Z. Instead of reversing the FOIL method, when you're factoring a trinomial, you're reversing the FOIL method. When you're factoring a trinomial, you're reversing the FOIL method. Here, for this binomial, we're reversing the distributive property. We're just reversing the distributive property. Z times what gives us 2Z squared? You had two factors of Z. You took one out, which means you're left with just one factor of Z. So 2Z minus, you tell me what we have here. We had a minus 9Z. We took out that Z, so we had a minus, what did you say? 9.
Mm-hmm.
You're still using the zero factor property. You set each factor equal to 0. That's going to give me the first factor. Set it equal to 0. It's already solved. There's my first solution cut point. Set the second factor equal to 0. That says 2Z is equal to positive 9. Divide by 2 to get Z equals 9 over 2 for my second solution cut point. How will we label these solution cut points? Closed. Solution cut points, you look at the original inequality. There's equality, so closed circles. Second step. Can we skip it? No. Our original problem, you see that fraction, you can't let the denominator be 0. So number 2, Z minus 4 cannot equal 0. So Z cannot equal 4 for my denominator cut point. That's an open circle.
Always
open. You don't look back here. People get the hang, look at the inequality, decide how to label it, and invariably they do the same thing for the denominator cut point. If you plug in a 4, over here on the right side you get 8. You'd have a 4 over 0. Is 4 over 0 bigger than 8? Is 4 over 0 even a number? No, it's not even a number. So you can't say that it's bigger than 8. You never shade denominator cut points. I didn't ask you all this. I saw some squares. Are we going to have to check every interval? Do we have a perfect square factor popping up? Mm-mm. Two distinct factors, a monomial factor and a binomial factor. So even though we have 3 cut points to label, how many intervals do we need to test? Just 1. Can we test 0? No. 0 is one of the cut points. So
be careful
labeling these numbers. Remember, you must label them small to big.
And you know what I'm going to do? That fraction is the thing that gives me a little...
You get messed up with fractions, don't you?
I'm thinking that, students might have trouble labeling that 9 over 2.
Of the 3 cut points, which one will I label first? 0 is the smallest. Then it's not either going to be 9 halves or 4. What will I label next? 9 halves. Maybe look at what Tony did there. 9 divided by 2 is 4.5. 4 goes next, and then 9 halves.
And now, put the open and closed circles where they go.
What do we have?
Imagine just thinking it through.
Okay, here.
Open circle here, closed circle there.
So we closed in 0. What about 4? Open. 9 halves.
The original version of this cut point method, when we saw it the first time ever, he didn't tell you this part
about how to label them.
And this part. All he said was plug in every cut point and decide if it's true or false. If it's true, closed circle, false, open.
Okay. We've already said it's going to alternate. We didn't get any perfect square factors, so we only have to test one interval. I can't test 0, so what's a number close to 0? That's 1. Which interval contains the number 1? Interval 1, 2, 3, or 4? 2. 1 is between 0 and 4. So I'm going to test 1. We're going to get 1 over 1 minus 4 is negative 3. So we have 1 over negative 3 is bigger than 2 times 1 is 2. Negative 1/3 is bigger than 2. False.
Negatives are never bigger than positives.
So we cross out. Any questions there?
Let's see why we're saying it's false.
We're plugging into the original inequality. The top is a 1. Then 1 minus 4 is negative 3. Is greater than or equal to 2 times 1 is 2. So we cross that out. Suppose we had tested negative 1 or negative 10. What do we expect? True. Suppose we had tested, that's a 4 and a 4.5. So we could have tested 4.1 or 4.2. That's what's so nice about knowing when you can just check one interval. Otherwise, you'd have had to check something like 4.1 or 4.2. But here, if we had checked it, true or false, what do we expect to happen? True. The alternating pattern here. Okay. Fifth and final step, interval notation. Call it out as if you were typing it in. Parentheses, negative infinity, comma, 0. So that's the first interval. Bracket or parenthesis, bracket. That's saying all the numbers to the left of 0, including 0, or there's an open circle, so a parenthesis, 4, comma, 9 over 2. What will go after the 9 over 2? Bracket. Any questions there?
Type it in.
Okay, type it in.
Parentheses. Negative infinity, comma 0, bracket.
Union, left parenthesis, 4, comma, 9 over 2, bracket.
Do that, it's going to count it wrong.
Get out of the denominator before you type your bracket. Any questions there? Yes. No, I don't believe so.
I think that here
The instructions say integers or fractions. Okay? Now,
It's nice to
we never
teach
read those things. We need to do what that person was telling their class. Study the instructions. Well, I knew the instructions, and so I didn't. I should have pointed that out to you. I don't believe there's any time that they'll be using decimal values.
If there's only, I think maybe, were there any dollar cents in the last assignment?
Maybe. There might be some dollars cent, but otherwise, no decimal lend itself well to decimals.
But it was good to think 4.5 so you know where it goes, okay?
But, yes.
Mm-hmm.
You could type it as a mixed number also.
I think if you wrote 4.5.
4.5, but they would take that.
But if you're going to use a mixed number, you got to use the little
mixed number hot button.
Yeah.
Okay.
And I
Number?
thought I saw that you want to do number 9 next.
Yes.
And we'll go back to number 7, it looks like. But when you do this, right here, it would let you type in, say, 4.5.
4. 1.
But that's more effort than the 9/2. So that's why
It's funny, in high school, I remember, even in algebra class, I'd convert those improper fractions to mixed numbers. Wasn't until I got into college, I remember right off, Mrs. Welch, she just stopped there. And I remember going up to her, no, you don't need to write that as a mixed number.
You didn't finish it. It's 4.5, and you left 9/2. But back then, there weren't any computer saying right or wrong. We were just, oh gosh, surely we didn't actually go up there and tell her we thought she'd messed
No,
up.
I went and asked her, is it okay? Because I was always told, and she told me, get out of that habit, which I did.
How does number 9 differ from the other ones?
It has the absolute value. Now, what's the first step in solving an inequality? Y'all see? Point to that inequality, okay? This is an inequality. What's the first step in the cut point method? Make it equal. That's why we solved absolute value equations the last time. I said I was getting you ready for today's assignment. So,
Wait, always?
no, before we do anything else, I'm writing the problem down. They know.
This is
The
not
absolute
12x
value.
plus 51.
I used to use red, but I'm trying to use less red and oranges because of accessibility issues. And
Yours looks like 12x plus 51, but it is.
maybe okay there. Does that make it? Well, now it looks. That's not too long. I mean, now it looks even
wait.
worse.
Let me make sure you didn't miscopy. 2x plus 5 minus 12. Okay, I was thinking it was less than 3, but no, less than negative.
I remember solving an absolute value equation the last time, and I said if you're solving an absolute value equation, you need that absolute value isolated before you do anything else. The same thing is true with inequalities. You need that absolute value isolated before you do anything else. Well, what do we need to do to get that absolute value by itself? Add 12, so that's what I'm going to do. I'm going to move that 12 over by adding it to give me the absolute value of 2x plus 5 is less than negative 3 plus 12 gives me a positive negative 3 plus 12. It's not a trick question. 9, okay. And at this point, I would advise that you never look back at the original problem. Treat this one, the rewritten inequality, that is what you want to work with from there on in. And as the absolute value expressions get messier, hopefully you'll see why this is better.
Checking.
So pretend this is the new problem. We're using the cut point method.
Hey, do we have to do step 2?
Will we have to do step 2? No, because there's no fraction. We'll do step 1. Find. We have the absolute value of 2x plus 5 is equal to a positive 9. Do y'all remember that? What do you do when you have an absolute value by itself on one side equaling a positive number on the other side? That looks funny. This is a star. I'm trying to say this is the thing I'll use from here on in. When it comes time to test, I'm going to use the rewritten inequality. Okay? Y'all remember, how many solutions do I expect to have? In order to have an absolute value equaling 9, that stuff inside there must equal positive or negative 9. Where is all that stuff?
I wasn't here the last time, but when I got here, y'all were gone. But this is
Okay,
where you're
here.
doing the equals 9, equal positive, equal negative.
Y'all remember this? We'd have an absolute value equaling here on number 7, we had an absolute value equaling a positive 13. So we got n plus 3 equaling a positive 13, and then that same stuff equaling a negative 13. Y'all remember doing that? Because that's what we're going to do here.
Equal negative.
2x plus 5 equals a positive 9, or 2x plus 5 equals a negative 9. Subtract 5 to give me 2x equals 9 minus 5 gives me a 4. And then divide by 2 to give me x equals positive 2 for my first solution cut point. How is it going to be labeled on the number line? Open, because there's no equality. Then this one, subtract 5. Negative 9 minus 5 gives me 2x equals negative 14. Divide both sides by 2 to give me x equals negative 7 for my second solution cut point. We've already said both of those will be labeled with open circles. Number 2. Skip. There's no fractions, so there won't be any denominator cut points. And I'm just doing these, I'm labeling the steps like this just to try to reinforce that I'm following through that 5-step recipe. When you're working it out, you don't have to number those steps. You don't have to write skip for number 2. I'm trying to show you my thought process here. Step number 3. I draw the number line there and there, and let's see, which one do I write first? The smaller one is negative 7, and then a positive 2. We said they were open circles. Step number 4, what do I need to do? Test what number? Oh, by the way, there is no factoring, no repeated factors, so I don't need to test every interval. I'm only going to test one. What number do you think I'll test? Which interval contains 0? Interval 1, 2, or 3? Okay, so I'm going to test 0. 0 is between negative and positive. That's how I know 0 is in that middle interval. Plugging it in, I'm not using the original problem. People mess up too much when they use that original problem. Plug it into the rewritten form. We have the absolute value of 2 times 0 is 0, plus 5 is less than 9. 0 plus 5 is 5. What's the absolute value of 5? 5. Wait. Positive 5. Whether it's positive or negative on the outside, when you take the absolute value, on the inside, whether it's positive or negative on the inside, when you take the absolute value, the result is always positive. Is that a true statement? Yes, so we shade. Suppose we had tested negative 8. Here, what do we expect to happen? Cross out. Suppose we had tested 3 or 30 over here. What do we expect? Cross out. Fifth and final step, interval notation. Call it out as if you were typing it in. Parentheses, because we have an open circle. It's hard to tell. Parenthesis. Negative 7. Notice the negative infinity part is crossed out. So negative 7, comma, 2, parentheses. Looks like an ordered pair, doesn't it? When we get to graphing next, is it
next class?
Yeah, next class meeting. That looks like an ordered pair. Now, an interval that has an open dot on each end is called an open interval. This is an open interval. An interval that has a closed dot on each end, like that first example we did, that's called a closed interval. This is an open interval.
Like the previous example, those were the first one. Oh, it's half open, half
It's
closed.
neither open nor closed,
Or
half open, half closed.
open. I like to say half open.
I always say it's neither open nor closed.
Okay, I got to take
Or you
that
can say
answer
it's
in.
open at this endpoint and closed at the other endpoint.
Parentheses, -7, comma 2, close parentheses. Check it. Now we're going back to 7.
Yes, we're going back to 7. 7 and 8 are real similar. Number 7. Solve the inequality. Once again, nowhere do they mention cut points. When you see a problem with a less than or a greater than,
Should I change it and try to get a different number here?
okay, if you want to.
Oh, no, okay, well, nothing. Forget it. I'll be fine.
Okay, please. 2y minus 5 is greater than or equal to 10. Hey, are we going to have to move stuff around the way we did it in the previous problem? No, we already have the absolute value isolated by itself. So, we make it equal. It's an absolute value equaling a positive number. That means the stuff inside has to equal positive 10, or it's going to equal negative 10. Solve the two equations. The first one, I'll add 5 to give me 2y equals 15, 10 plus 5, and then divide by 2 to get y equals 15 over 2. How am I going to label this thing when I label it on the number line? Closed, because there is equality. I'll make a note of that right now. Solving the second one. We add 5 to get 2y equals. We have a negative 10 plus 5, negative 5, and then to give us y equals negative 5 over 2 for my second solution cut point. Any questions there? What about step 2? This was step 1, setting it equal. Step 2, skip because there's no fractions. Once again, I'll write that out even though it's not really necessary. Step 3, we're drawing our number line. We have 2 cut points. Remember, they go small to big. Which one do I write on the left? Negative 5 over 2. And then a positive 15 over 2. And we said they were both closed circles. Hey, you think we need to check every interval? Or can we just assume an alternating pattern and check only one?
Did you factor
Did you
anything?
factor? Did you run into any quadratic expressions? Any exponents? No. So we can assume.
Statement that you wrote. Maybe it'll make more sense to us.
Okay, let's see if I can find it. If there are no repeated factors or no exponents, you can just check one interval and assume an alternating pattern. Does that make more sense now? Okay. Which number do you think I'm going to check? You said we only have to check one, so which one do you think I'll check? 0. Which interval contains 0? Interval 1, 2, or 3? 2. 0 is always between a negative and a positive. So we're going to test 0.
I started saying that phrase, 0 is always between a negative and a positive, one semester when a student was having so much trouble. She asked, why is 0 moving? And I was like, 0's not moving. It's the cut points that are changing. So she was like, well, in the previous one, 0 was in the third one. Here it's in the second one. Over there it's the first. You're looking at where is it between a positive and a negative. Well, you can't use 0.
Okay.
Right.
0 is always between a negative and a positive. That's how you decide where to label it. Which interval 0 is located in. Plugging in a 0 into the absolute value inequality, we get the absolute value of 2 times 0 is 0. So we have 0 minus 5 is greater than 10. 0 minus 5 is a negative 5. What's the absolute value of negative 5? Positive 5 is bigger than 10. True or false?
Notice how he just waited until he actually found the absolute value before finding true or false. That's going to be significant in the next one.
You could have wound up, suppose we had wound up, I'll see people with a negative 15 in here. Negative 15 is bigger than 10, and they'll say false. They forget to take the absolute value. You've got it. That's a negative 5. When you take the absolute value, it becomes a positive 5. In this case, it's still false, okay? So cross out. Over here, that means we have to shade it. So it's going to be, here we're going to have negative infinity in our answer. Over here, we shade. So we're going to have a positive infinity. Fifth and final step, interval notation. Call it out as if you were typing it in. We go left to right. So, parentheses, negative infinity, I agree, comma, negative 5 over 2, and put a bracket, because negative 5 over 2 is shaded, or, so we use the little union from the toolbar, the second interval, bracket, because 15 halves is shaded, comma, infinity, parentheses, for my final answer.
If you're a view and example person, I'll warn you. This is the time that the view and example is doing it differently. Pearson gives you some different rules to follow when there's absolute value bars. I don't think that's the way to do it. Cut points will do everything. Well, I memorized 2 new rules that fall apart on the next problem.
On the next problem, their little method would fall apart. Or does fall apart.
Mm-hmm. Okay, so I type parentheses, negative infinity, comma, negative 5 over 2, right arrow, bracket, union.
The union comes from the toolbar, bracket,
15 over 2. Don't put the comma in the denominator. I'm almost sure if you do this, at this point it's counting it wrong. So I'll go right arrow, comma, infinity,
parentheses.
Oh, it's getting slower and slower.
Something's going on.
Okay.
Number 11. Looking at number 11. write this problem down. Number 11, we have the absolute value of x squared plus x minus 4 is greater than 2. The absolute value of x squared plus x minus 4 is greater than 2. Well, when I look here, I think to myself, at least I don't have to move terms around. Notice we already have the absolute value by itself on one side and the number by itself on the other side. We don't have the absolute value with something added or subtracted from it. So we don't have to move any terms around. The first step, we replace the the greater than with an equal to. And we have an absolute value equaling a positive number. So that means the stuff inside there has to be either positive 2 or negative 2. The only way an absolute value can equal 2 is if the stuff on the inside is equal to positive 2, I know, or negative 2. Negative 2, yes. When you were gone on Wednesday, I made up an example. I didn't really make it up. I looked ahead to see what was number 11 going to be in today's assignment. Look at that. Look at that equation we just solved, that we're going to have to solve. Look at what we did there. Here it is. This looks familiar to me. Isn't that what we're going to have to solve right now? X squared plus x minus 4 inside the absolute value bars equaling 2? Yeah, that's what I was just trying to get you ready for this problem. But that's why I made up this example in class on Wednesday. I wanted to get you ready for this. Yes, it's going to be tedious because it's two quadratic equations, but it's not something that we haven't done before. We have to get it set equal to 0. X squared plus x minus 4. X squared plus x. We have a negative 4 minus 2. That gives us a minus 6 is equal to 0. And it's a simple trinomial, so we're just going to have an x times x. What do we know about the signs? Okay, there'll be 1 plus and 1 minus. How about a positive 3 and a negative 2? Does that do it? That gives us back that positive 1x. So we're getting two different solution cut points here. What will we get from the first one? Negative 3. And this one? Positive 2. So we just found two solution cut points. And how are they going to be labeled? Open or closed? Which one? Open, because there's no equality. The second one, we have to get it set equal to 0, so I'm going to add 2. That'll give me x squared plus x. Negative 4 plus 2 gives me a minus 2. And then I write my two sets of parentheses. X squared, x times x. What do we know about the signs? 1 plus and 1 minus, just like the previous case. So what about a positive 2 and a negative 1? Does that do it? Yes. So we're about to get two additional cut points. What are they? -2, and +1.
Any repeated factors?
X plus 3 for a moment right there, but no. That's an x minus 2, an x plus 2. They're all different factors, so we can assume an alternating pattern. This is the first time we've had this many cut points. How many cut points do we have? 4, but there's really no extra work in terms of testing because we know no repeated factors, so we can assume an alternating pattern. But look back at this. 2 and -3, 2 and -3, 1 and -2. Yep, we got that. I was just trying to warn y'all that we would wind up with some absolute value quadratic equations to solve in this assignment. Sort of long because you got to factor twice, yes. But not too bad. They're simple trinomials. That's what I say. That when the problems get more involved, it's amazing the way they have the programming set so that, okay, it won't be, you're not going to have a 14x squared plus 7x minus 18 to factor. It's, I mean, they're taking into account, okay, this problem is sort of long, so make it the factoring part easier. Second step. What do we know about the second step, the denominator cut points? You skip. There's no denominators. Third step, we draw our number line. That's -infinity. Well, there's positive infinity. Now I'm just going to put the 4 dots equal spaced, even though the intervals may not be that long, okay? And the cut points have to be put in numerical order. We know they're all going to be open circles. I'll do that right now. And I know they're open because there's no equality up here. Now call them out. What's the smallest cut point we have? And here? Here? 1, and then finally 2. If we didn't know that this was going to alternate, we'd have to, I guess we could use -2.5 here, but as it is, it's not bad at all. What number do y'all think I'm going to test? 0. Which interval contains 0? Interval 1, 2, 3, 4, or 5? 0 is always between a negative and a positive. I agree with interval 3. We're going to test 0.
After class today, if someone asks you, what did you learn today in algebra class?
You can say, I can label 0 on a real number line. You give me the real number line, I can label 0.
That's a joke.
But there's actually more involved in it than you would think, okay? But you have to plug it in. The 0 is between a negative on the left, a positive on the right. Plugging in 0, we get 0 squared, which is 0, plus 0, minus 4 is greater than 2. Okay. 0 plus 0 minus 4, that's a -4. True or false?
This is where some people say false, but wait. We're not through.
We're not through. What's the absolute value of 4? People want to say, what's the absolute value of -4? +4. Before you decide true or false, you better find that absolute value. Because here, -4 is bigger than 2, false. But it's not -4. It's the absolute value of -4. The absolute value of -4 is a +4. 4 is greater than 2. True. So we shade. Here, if we had tested that -2.5, would we have shaded or crossed out? Cross out. Here, shade. Suppose here we would have had to test 1.5 or something like that, but we didn't have to because we know it's going to be crossed out and shade. Am I going to have any square brackets in my final answer? No, it's all parentheses. So parentheses, negative infinity, comma. I was going to let y'all call it out, and I forgot what I was doing. So parentheses, union, parentheses, negative 2, comma, 1, we're right here, parentheses, remember we said they'd all be parentheses, so I'll do a union, parentheses, 2, comma, infinity, parentheses.
Oh, wow, this is just so beautifully done here. This is such a nice way of solving this type of inequality.
Okay, before he types in the answer, I want to ask you something. Would we have done anything different if instead of a greater than, that is said a less than? Would anything be different? You still have to go through all this, right? But if it had said less than, when we tested 0, instead of shading it, what would we have done? Crossed it out. Instead of crossing this one out, what would we do? Shade. And so the cut point method works. It doesn't matter whether it's a less than or a greater than. The only difference is the number. When you're testing, if it says greater than and it's true, when it said less than, it would be false. But the cut point method solves it, whether it's a less than or a greater than. If you view an example, you better be careful, because their little method that they do, that I'm convinced the programmer doesn't.
First of all, how many number lines should you be?
How many number lines do we have? One.
Only one. This strange method they're doing here. Look, they're finally at this point.
They still have to do the factoring. Do y'all agree that my method, the messiest part is the factoring? They still have to do that. Okay?
Right, they did what? They factored this one to get the first 2 cut points.
Tony, did you type in the answer?
No.
That means they're not going to give. They're not going to let you type in the answer.
Oh my gosh! Is it going to change it?
No, it did. Oh, okay, good.
Oh, let me type it in.
And
then we'll look at that.
I hate to
the
do
mystery.
It's a
They
mystery.
draw 3 number lines.
They draw 3 number lines for this one problem. How many number lines will you have for an inequality?
With the cut point.
With the cut point method, only 1 number line.
You can go and impress people by doing this problem. Or tutors. Because a lot of tutors would wind up doing what the viewing example does.
And then you ask them, okay, this is great, but how do you do it if it's a less than? I guess I know what you would do. You'd say, oh, wait a minute. There was a movement, I guess about 20 years ago, instead of putting the open and closed circles, they would put brackets in place of closed on the number line and open circles in place of parentheses. With that in mind, they want you to choose the number line.
Which one
and
should
in place
be?
of open circles, what should we have? Open circles are parentheses, so A, B, C, or D.
D.
Mm-hmm.
Now, going back to this viewing example, it's just a mystery. We've gone through it before, following the logic, and
Okay. They're getting their first number line, and they're getting intervals.
They're testing the intervals with just the first 2 cut points.
Why are they doing that?
Then they're now showing for they are now.
Now they're ready to begin factoring. They're ready to begin the second half. All that, it's just the first half. Then they keep on going. They do the second bit of factoring. They get a new number line.
And they shade this new number line.
And then, by this point, they know no one's paying attention. They're lost. They have no idea what's going on. They'll just pop out the final answer. And I think that's what the
And
programmers
from
did.
the final answer, then they drew the last.
Number line. They get the final answer, and then they drew the last number line.
Wow. Now, number 12 is the last one, and it's similar to this one. It's 3:59. We could call it quits and be done at 4, or we can do number 12. Y'all didn't speak, so we'll do number 12.
Okay.
You have to go, okay. But starting with number 13, it's just a review of some other stuff.
Complex numbers.
Complex
imaginary numbers. I looked. Generally, I never look and see what, and I was like, oh, I hope it's not something real messy, because these problems are long enough as they are.
But
and
they could always be worse. We could be using doing the view and example method.
We could be thinking about it.
Yeah. Maybe that's what they were doing with the view and example.
That's what they were doing, is thinking.
Okay.
Absolute value of x squared plus 3x minus 7 is greater than 3.
You know what, Tim? I'll
What?
do this one. Since I haven't written anything today, I got to practice my penmanship, even though it's not as good as yours. Okay. And you've already told them how to do it, so I think it's not on, is it? But for just a second, wonder what's going on. Now is it on?
Yeah, lower
Okay. Lower my microphone.
Yeah, lower the
Okay.
I turned mine off.
You did?
No, I didn't.
Oh, okay. They're gonna mess
That's
up.
the problem with yours.
Okay, I've written down this problem, and it's a quadratic absolute value inequality. Anytime you see a less than or greater than, and it says solve, think cut points. Pearson will never say cut points, but you know cut points. Pearson has a lot of other little rules to do something like this, but all you need is cut points. So start off by solving the equation. So step 1. Here. I'm solving the equation. Absolute value of x squared plus 3x minus 7 equals 3. What numbers have absolute value equal to 3? Well, 3 or negative 3. This is what y'all did the last time. Solving these absolute value equations. Go equal positive and equal negative. Now, let's see. What am I going to have to do to solve these equations? Okay, subtract 3. So subtracting 3, we'll have x squared plus 3x minus 10 equals 0. Is it going to factor pretty easily? Yeah, it's literally programmed to factor easily, okay? So x and x. For 10, 1 times 10 or 2 times 5. Keep in mind we want numbers that subtract to give a positive 3. 2 and 5. How do I arrange my plus and minus sign? Plus on the 5 and minus 2. Setting each factor equal to 0. X equals positive 2. And x equals negative 5. These solution cut points have what sort of circle on them when we label them? Open circle. Now doing the equal negative 3. Notice, with my method, you don't draw a number line yet. You get all the cut points first. I should say our method. Add 3 to both sides. X squared plus 3x. Let's see, minus 7 plus 3. Is that going to be a minus 4?
Yes.
Equals 0.
That purple looks fuzzy to me.
I'll just use blue. You should have told me. X.
Just got
X and X. 1 times 4 or 2 times 2? 1 times 4, because we need 2 numbers that subtract to give a positive 3. And how do I arrange the signs? -1 and plus 4. Okay. Setting each one of these equal to 0. The first one we get is x equals positive 1. And the second one, -4. Do we have any denominator cut points? No, of course not. There's no denominators. So no denominator cut points because there's no fractions. Let's draw my number line. This green
is going to.
I'm going to have to buy some more pens. The school provides us with pens, but I'm too picky, I suppose. So we have 4 cut points. I'll put 4 marks. Label them in numerical order. Which one's closest to negative infinity? -5, then -4, 1, 2. All of them open cut points, right? Can I test 0?
Yes.
Yeah. And where is 0? Interval 1, 2, 3, 4, or 5? 3. 0 is always between a negative and a positive. Test 0. And that's absolute value. So I'm plugging into...
Remember, you plug into the inequality, not the equation. It'll always be false in the equation. You're testing the inequality.
So plug in a 0. 0 squared is 0. 3 times 0 is 0. It looks like it's going to be... You might think false, but wait a minute. This isn't -7. It's the absolute value of -7. With absolute value, that means drop the negative if there's a negative on the number. So 7 is greater than 3. True or false? True. So shade. And I'll finish it up from there. Cross out. Shade. What about this one right here? Between 1 and 2, if we'd plugged a 1.5 in, we would have gotten it false. If we plugged a number bigger than 2 in, what would we have gotten? True or false? True. Okay, so call out here's step 5, writing it in interval notation.
Step number 4 for the testing.
Yeah. Okay. 4 is the testing. Now, number 5 of interval notation, I'll get us started.
Are we going to have any square brackets? No. Okay.
Parentheses, negative infinity, comma, -5, close parentheses, union. What am I going to do next? Parentheses, -4, comma, 1. Again, sometimes In the past, I've seen students that they just write the interval notation for every one of them. That's why we put an X there. It's trying to say, don't write that one. That one's wrong. Then one more union, and
I'll call that as a U. I'll say U, but you cannot use the U from your keyboard. You have to use that U shape from the toolbar.
I'm going to type it in.
Oops.
Nice way of solving quadratic absolute value inequality.
And once again, there is no negative infinity hot button. There's only an infinity hot button. You have to type the negative from the keyboard yourself. And I call this a U, but you can't use the U from your keyboard. So
and when you say things over and over like that about the negative infinity, it's only because they've gotten those questions repeatedly about negative infinity. Where's the negative infinity button?
We're not through. A, B, C, or D. It's not brackets because we don't have any closed circles. So it's either A or C. C?
Mm-hmm.
And then after that, I think it's imaginary numbers. We know that answer. What's that answer?
I'll get you started. 7.
The square root of 49 is 7, but since it's negative, you stick on an I. Okay. Now, any questions you want recorded? No? Okay.